Okay, so this is to answer Kaylee's question about exercise 1 star. So what we're doing is we're using the graph of y equals x squared for -4 to +4, and we're going to use these graphs to solve the equations below. So we've got this one first, number 1, x squared minus x minus 3 equals 0. I'm just going to rearrange this slightly to plus x plus 3 because we're using the original graph of x squared in order to solve it. So this is why it asks you to draw the graph of y equals x squared, and y equals, on here we're going to draw y equals x plus 3. Now I can't really do this accurately on here, or actually I can use a ruler for that. But I can, oops. I can do a rough estimate of how to do this. So let's do roughly y equals x squared. Okay, it's roughly that. Now we're also going to draw, I'm also going to draw, that should go through the origin down there, sorry. And then I'm going to do another graph of y equals x plus 3. Okay, I know the graph looks something like that because that's going to be 3 where it passes through the y-axis, and that's going to be -3 where it passes through the x-axis. I know it's a 45-degree angle because the gradient of the graph is 1 because that's the coefficient of x. So then when you've drawn it on your own graph, you can just drop that down to the x-axis and find out whatever that is. And similarly over here, you can drop that down to the x-axis and find out the other thing, the other value. The next one, x squared plus 3x plus 1 equals 0. Again, I'm going to do the same thing. I'm going to rearrange it so I've just got x squared on one side. I'm going to take away 3x and take away 1. So now I've got the graph of y equals x squared, and I need to now put on there y equals -3x minus 1. And so I know that the y-intercept is going to be down there, but I'll draw a slightly different version. I'll draw a with a blue, I think, because we all like blue. And here we go. And there we can see that there are going to be 2 more solutions there, where you've got this x here and this x here. Whatever value your x is there, and whatever value your x is here, sorry, and here and here, those are going to be your 2 solutions. And let's just do one more. Let's do this one in green, because I like green. We've got x squared minus 4x plus 4 equals 0. Same again. We're going to get x squared equals 4x minus 4, because we have to add 4x and take away 4 to get rid of it on the left-hand side of the equation. We've got y equals x squared because we drew it correctly before, and we need to now draw y equals 4x minus 4. So actually I need to extend this line down here just a little bit. I'll use a ruler this time, but -4 should be somewhere down here. I will, however, use the ruler to draw my graph. I know that the gradient is 4, which means I'm going to get one solution here, and another one is going to be all the way up there. As I said, it's because my graph, my x squared graph isn't particularly accurate. If I were to, however, go into something like Desmos and do it a little bit more accurately, I've got this y equals x squared here, and I can put in those graphs as well. I've got x plus 3, so you can see those are your two solutions, negative 1.3 and 2.3. Okay, we've got another graph which I just did, which was negative 3x minus 3. Negative 3x minus 1. And if I zoom in a little bit, I can also see I've got a solution there, and I've got a solution there. So negative 0.3 and negative 2.6. Those are my two solutions for that one. And finally, what we had 4x minus 4, 4x minus 4. Oh, okay. So my graph was a bit off, but I can see here that there's only one solution because the graphs only meet at that one point right there. At that point right there. So for that one there is only one solution, and I think that actually makes sense algebraically, because if we've got this graph here, I can actually rearrange that to x minus 2 times x minus 2 equals 0, which actually multiplies out to give x squared minus 4x plus 4 equals 0. So there's only one solution to this, which is where x equals 2. Okay, hope that helps.